Hi students, in this video we are going to see about metals and non-metals, which is a continuation of the topic from your 8th standard syllabus. Okay, so metals and non-metals. So first let us see what is metal and what is non-metal, and then we will see what is the difference between metals and non-metals. Okay, so metal. So what do you know about the metal? First let us see metals. Metals are lustrous, right? Then what else you know about the metal? They are good conductors of heat and electricity. So at home if you see the cooking of utensils, they are metals. Am I right? So when we keep it on a gas stove, it gets heated up and the food gets cooked faster, right? So metals are good conductors of heat. And if you see, we enjoy electricity in terms of fan, light, am I right? So the fan, you would have seen the wires, different color wires you would have seen. Inside that wire you would have seen the copper, correct? Copper wire. So it is metal, it's a metal, no? Copper is a metal. So they are the good conductors of heat and electricity. So good conductor of heat and electricity. Then what else you know about metal? They are malleable. If you take say aluminium metal and you are going to take a hammer and go on hit them, okay, go on hit with the hammer, so it will become thin sheet. So that's called malleable. Okay, so metals are more malleable. What is malleable? Making them to thin sheet, then it's called malleable. And they are ductile. What is ductile meaning? We can make it into wires, thin wires. Okay, that's called ductile. You would have seen, no, for electricity we use say copper wire, right? So which is the most ductile metal? Anyone? Which is the most ductile metal? Gold. Gold is the best, most ductile metal. You can make it into thin wires. Alright, so that's nothing but ductile. So the malleable best example will be aluminium. You can make it into thin sheets. And the most ductile metal is going to be gold. Which is the best conductor of electricity? Anyone? Which is the best conductor of electricity? It's silver. I can hear you saying copper, but actually it is silver. Okay, the most or the best conductor of electricity is silver. The next will be copper. Copper is cheaper, so that's why we use copper wire. Alright, yes, so the metals are lustrous, they are lustrous, shining, no, it's very shining when you see any metal, gold or platinum or silver. So it's so lustrous. They are the good conductors of heat and electricity. They are malleable, they are ductile. Yes, so these are the properties of metal, I can tell you. Now what is the proper definition for metal? What is metal? The metals generally loses its electrons. The metal has the tendency to lose electrons, donate electrons, give electrons. So sodium, that's why we say the valency for metals are always positive. Why they are positive? Because they donate electrons. So sodium, it has atomic number 11. What is the configuration for sodium? 11, right? What is the configuration? 2, 8, 1. So when it loses one electron, it reaches octet. So what is the valency of sodium? It's 1, plus 1. So what do you think? The metals are negative? I mean, they gain electrons or lose electrons? They lose electrons. Always they lose electrons. Okay, they donate electrons. In order to attain the octet, they generally lose electrons. For example, magnesium, atomic number is 12. What is the electronic configuration? 2, 8, 2. Now here 2 electrons is extra, right? So it donates 2 electrons. So what is the valency of magnesium? Plus 2. What is the valency of sodium? Plus 1. So what is a metal? Metal generally loses electrons. They donate electrons. They have tendency to donate electrons. Then it's called metal. Alright. So metals are always have positive valency. They always give electrons. They have positive valency. Alright. Yes. And now let us see non-metals. What are their properties? And then we will see difference between them. Alright. So the next what we are going to see is non-metal. So non-metals, they are non-lustrous except, what is the exception? Except iodine. You can tell graphite, right? Graphite are lustrous, you know. Graphite are lustrous, iodine is lustrous, but they generally, these are the exceptions. Apart from that, generally non-metals, they are non-lustrous, they are non-malleable. So now I am going to take the lump of sulfur, okay. Lump of sulfur means the sulfur, and I am going to keep it here. With the help of the hammer, I am going to hit it. So what you will observe? It will break into pieces. Okay, they are non-malleable. But you saw in metals what happened? When you hit with the hammer, it will go on, it become thin sheet. Okay, so non-metals are non-malleable. They are non-ductile. You can't make it into wires, right? It will break. So whether they are good conductor or bad conductors of heat and electricity, they are bad conductor. Okay, they are bad conductor or insulator. Except, what is the exception? Except graphite. Can anyone tell me what is graphite? Whether the graphite is made up of which element? And what is diamond is made up of? So graphite, diamond, all are made up of carbon. You know carbon is a non-metal. But diamond is the bad conductor, whereas graphite is a good conductor. It's very, very important to know this. So diamond is a bad conductor, whereas graphite is a good conductor, but both of them are made up of carbon. So why diamond is a bad conductor? So diamond is a bad conductor because carbon valency is 4. The carbon is surrounded by 4 electrons, and those electrons are connected with another carbon atoms. So there is no electrons free in diamond. Whereas in graphite, among those 4 electrons, only 3 will be bonded and 1 electron is left free. And because of those free electrons, graphite is a good conductor. So you know very well the conducting current is because of either electrons or ions. So graphite is a good conductor because it contains free electrons. Whereas in diamond there is no free electrons, therefore they are bad conductor. Alright, hope you guys understood. Yes, so non-metals are non-lustrous except iodine and graphite. They are non-malleable, they are non-ductile, they are bad conductor in general, but except graphite. So what do the other properties does non-metal have? Whether they donate electrons or they accept electrons. See, in general, metal or a non-metal, whether it is losing or gaining electrons. Why this should happen? Because in order to attain stability, it will either lose electrons, any element, or it will gain electrons. So non-metals generally they gain electrons. Okay. So for example, Cl. Let us take Cl. The atomic number is 17. What is the configuration? 2 8, 7. When any element has 8 electrons in their outermost shell, they are said to be stable. Octet, no, it reaches octet structure, which means they are stable. So when chlorine accepts 1 electron, it reaches octet. So therefore, when it accepts 1 electron, it becomes 8, right? So the valency is -1. In chemistry, loss of electrons means positive, gain in electrons means negative. So here it is gaining 1 electron, therefore it is -1. So what is the definition for a non-metal? Non-metal will gain electrons. So therefore generally non-metals will have minus valency, negative valency. Let us take another example, oxygen. Oxygen atomic number is 8. So what is the configuration? 2, 6. You know very well when it reaches octet they are stable, but you have 6 here, right? So it accepts 2 electrons in order to attain octet, therefore the valency of oxygen is -2. Alright, understood guys? Yes. So non-metals, they are non-lustrous, non-malleable, non-ductile, they are bad conductor and they generally gain electrons, right? They are non-sonorous. So in a metal, when you hit with the hammer, you can hear a sound, right? That's sonorous. Whereas in non-metal, when you hit with the hammer, so it's not going to give you any sound, therefore they are non-sonorous. Okay. So now let us see the difference between metal and non-metals. Okay. So they donate electrons. So they gain electrons, right? So generally metals will donate electrons, whereas non-metals will gain electrons. They are good conductor. I am just writing the exception, not the exceptions, but general points. So here it is bad conductor except graphite, okay? Next point, they are malleable, whereas non-metal, they are non-malleable. They are ductile, non-ductile. They are sonorous, non-sonorous. Okay. So these are the important difference between. Okay. So the here the proper definition for metal will be metal generally lose electrons, whereas non-metal generally gain electrons. Okay. So now we are going to see what the reactivity series. What do you mean by reactivity series? So here I am going to teach you what is reactivity series and what are they, and how I am going to teach you the shortcut to remember that. Okay. Now let us see. Reactivity series. So what is reactivity series is based on their reactivity, based on how do they react with say hydrogen, with water, how vigorously they react with water, or they are not at all reacting. So based upon that, they have classified from more reactive to less reactive. Okay. Now let us see. No place I am writing here, it has to come down. Based upon their reactivity, the elements from more reactive to less reactive, It has been arranged. So lithium is more reactive and mercury is less reactive. Okay. So how to, for example, what is the use of me studying this reactivity series? You can say that whether the lithium can displace zinc, whether the potassium can displace lead, whether the copper can displace iron, so like that. And in your higher classes, you will be better knowing about this reactivity series. Actually, it plays very important role about whether the reaction will happen or not. You can definitely find out. Okay. So how to remember? Here is the shortcut. You just join this. Okay. Lignaka. Okay. So it's so funny. So funny way of learning. So you will never forget this. Liknaca. How to remember that? Lignaka. Okay. You can also say along with me. Okay. So lignaka. Megal zinc. MgAl. Megal zinc. Zn, you know it is zinc. So megal zinc. Fepeb. Fepeb. Okay. Fepeb. Agu petag. Okay. So funny way of learning this. So I guess you will never forget this. Okay. Till you finish your 12th, I think you won't forget. So let's give a chorus. Okay. So I'll read out and you can also read out along with me. Okay. So the lignaka, megal zinc, fepep, agu petag. So say it's just 4 or 5 times. I think you will be getting. So this is very, very important. It comes in your first chapter, that is chemical reactions. It also comes in metals and non-metals chapter. So on the whole, this reactivity series is very important. They will be asking questions from this. Okay. As a whole, it's very important. Alright. So once again, lignaka, megal zinc, fepep, agu petag. Okay. So you say 2 or 3 times, you will get it surely. Okay. So I hope you guys understood today's class. I hope it was interesting and let us see in the future videos. Okay. Yes. Thank you, students.